Hello, everyone. Hi, my name is Zuleika, and I'm in my third and final year of studying maths and physics at the University of York. And today we're going to talk all about exploring maths at York and why it is amazing and great, and you should do it and come here. I'm going to talk to you about what I personally have studied over my 3 years and how the course is generally structured. For maths and physics students such as myself, all modules taken in years 1 and 2 are compulsory, with options opening up for you in years 3 and beyond. I personally decided to stop at year 3, but I'll be returning in September for a postgraduate course in mathematical sciences. So, when you start university at York, here is what you can expect. So, lectures, seminars, first year, first term labs if you're doing maths and physics, computer practicals, problem classes. And in year 1, you'll probably have 10 to 16 hours per week of lectures, 1 to 4 hours per week of seminars, 1 to 3 hours per week of problem classes, and then 1 to 5 hours per week of practicals. And of course, there will be plenty of support for you from the undergraduate admin team and academic supervisors in each department. That is, if you're doing joint honours. If you're doing single honours, then your supervisor will just be in the maths department. So we are assessed through exams, extended assignments, weekly practice questions, formal reports, and presentations. And you might be thinking, oh my goodness, that is quite a lot. But trust me, everything is in place for a reason, and there is plenty of content to be assessed on. And that's just how university goes, really. I can't really say much more on that. But you'll feel satisfied when it's all done. So, come year 1, what I've done here, and also for the other 2 slides, is I've put down all of the modules I've taken and then some comments, some personal comments underneath of how I found them. So, year 1 emphasizes core material to consolidate your existing knowledge and prepare you for more advanced study. Mathematics modules in algebra and calculus serve as great foundations for the rest of the course, supported by Math Skills 1, which in hindsight was probably one of the most useful courses in that it taught us how to read and write mathematics. It is true when they say that maths is a language. Physics brought the introduction to thermal and quantum physics, along with a more mathematically challenging take, shall we say, on electromagnetism, waves, and optics. Please don't think that because you might have seen these subject titles at A level that you'll be bored or anything like that, because trust me, you won't. I also did a short course in classical mechanics and relativity with professional skills, including a Python programming course and first term practical laboratory sessions. Next, we come to year 2. Aha, we are aging. So year 2 is full of even more core modules, thus deepening your understanding of fundamental laws, processes, and techniques. So for physics, we had quantum physics, where it was broken down into quantum, particle, nuclear, and atomic, thermodynamics, and solid state. Wow, that comment was really not very helpful, what I'm seeing on the slide here, but yeah, that's another heavy module. And then electromagnetism and optics. Again, these are extensions of what happened in year 1. For maths, we have applied mathematics for maths and physics. So what happens in second year is the 3 streams become more apparent. So statistics, pure, and applied. And since I was doing maths and physics, I naturally went down the applied route. It wasn't a choice really, because that was the most natural transition due to the nature of my degree. So here I looked into classical dynamics, waves, and fluids. Then came functions of a complex variable. So this is essentially real analysis, but in the complex, like applied to the complex plane. Then here comes vector calculus. So as I could say, the true Hulk of calculus. This is a very useful module, and it really helps actually cement the physics. Then came linear algebra. So here we moved from linear properties in coordinate spaces back in year 1 to more abstract linear algebra. Then I did Math Skills 2, which involved Java programming and an independent project. So this was either programming or, oh, I just written extended there. That's meant to say extended assignment. So you had the option to pick one or the other. And I personally did the extended assignment. So I did like a research project. It was like 5 pages long, learn how to use LaTeX properly, which you'll come across if you haven't already done so before. And mine was a financial one. Yeah, very interesting stuff. Next comes year three. So year three is where all the choices start to hit, except for statistical mechanics and solid state, which was a compulsory module, and also the BSc project, because everybody in their third and final year must do a final year project. It's similar to a dissertation, if you will. So I'll just get the physics bit out of the way because this is technically a maths talk. So I did pick quantum physics 3, in which I looked further into quantum and nuclear physics. And then with statistical mechanics and solid state, it was quite confusing, but we got there in the end. Let's go into the math side. So I picked 4 modules myself. I picked linear optimization and game theory, which was definitely different for me because I'd done such physical mathematics. If is that, can I say that? Yes, I can. So here I applied new techniques to problems in operations research, finance, and economics. And this also formed a great basis for my final year project. So I selected applications of linear optimization and game theory, and I applied it within retail. Next comes partial differentials 1 and 2. So the second one led on very nicely from the first. So the first one was essentially an introduction to the basic properties and applications. And then the second one was more, I would say, we got taught how to put these techniques into practice, and we also applied them in MATLAB. And I had a really good basis for MATLAB because I'd taken modeling with MATLAB, and despite doing that in a more biological context, the skills were still there, so the module did make sense. And yeah, I think I've just talked through everything on this slide, so I'll move on now. And finally, here's just a bit of advice from me, which is please do your research, explore the course in full, and ask questions. If I could say something to, well, a little tip to my previous self, I would say, don't just look at the university, for the name or anything like that, or just, okay, this is a maths course, I want to do maths, but also look at what the courses are and what modules you could be taking, because every university structures themselves differently, and there might be a lecture course as a specific university, but it's not at any others. So do check it out, do your research, take your time, you have got time, look around and ask questions. Thank you ever so much. Take care. Bye.